Hey everyone, and welcome. If you're heading into a clinical career, you know you're just flooded with headlines and research papers talking about risk. You've got increased risk, decreased risk, risk ratios. It can feel like a whole other language. So in this explainer, we're going to break down what all this stuff actually means so you can look at a study and know exactly what it's telling you. All right, let's get into it.
And first off, I just want to give a huge shout out to Dr. Abdul Karim Iblasi and to all his amazing students in emergency medical services and nursing. We actually made this explainer just for you to give you a tool that's going to be super useful for your entire careers. All right, picture this because you're going to see it all the time. You're reading about a new drug and the study says it has a threefold increased risk of some side effect. I mean, threefold increased risk, that sounds huge, right? It sounds really bad. But is it? Should you be worried for your patient? Well, to answer that, you first have to understand what that number is even being compared to.
Okay, so to really get what threefold means, we have to go back to square one. We have to start with the most basic, the most important concept of all of this, and that's absolute risk. Seriously, everything else we're about to talk about is built right on top of this one simple idea.
So, absolute risk. It's honestly as simple as it sounds. It's the plain, straightforward chance of something happening. If you've got a group of 100 people and 10 of them get the flu, the absolute risk of getting the flu in that group is 10%. It's just what are the chances of this thing actually happening out in the real world? No comparisons, no tricks, just the raw number.
Okay, let's look at a clinical example from a paper by Dr. Chittaranjan Andrade to make this stick. We're looking at a table from a hypothetical study on an antidepressant. You can see two groups. One group of 40 people got the drug, venlafaxine, and another group of 36 people got a placebo. And the study was tracking whether they developed one particular side effect.
So how do we figure out the absolute risk for the folks who actually took the drug? Super simple. First, you look for the number of patients who had the event. In this case, the side effect. We see that's 8. Then you look at the total number of patients in that group, which is 40. Then you just divide the first number by the second.
You do the math, 8 divided by 40, and you get 0.20. That's 20%. So, the absolute risk of developing this side effect if you took venlafaxine, at least in this study, is 20%. Or you could say 1 out of every 5 patients on the drug had this happen. See, it's a real concrete number you can actually picture.
But you know, a 20% risk, what does that even mean by itself? Not much, right? Is 20% high? Is it low? You can't know until you compare it to something. And that brings us perfectly to our next idea, relative risk, or as you'll usually see it, RR.
And that's where relative risk, or a risk ratio, comes in. The name kind of gives it away, right? It relates the risk in one group to the risk in another. You take the absolute risk in your exposed group, the one that got the drug or had the exposure, and you compare it to the absolute risk in your non-exposed group, the ones who got the placebo. It's all about comparison. Let's use a super classic example to nail this down: smoking and lung cancer. So here we have a study that followed 100 smokers and 100 non-smokers over time. And as you can see, in the smoker group, 30 people developed lung cancer. And the non-smoker group, 10 people did.
Okay, to get our RR, first we need the absolute risk for each group, just like we did before. For smokers, it's 30 out of 100, so that's a 30% risk. For non-smokers, it's 10 out of 100, a 10% risk. Now for the final step. You just divide the risk in the exposed group, the smokers, by the risk in the non-exposed group. So 0.3 divided by 0.1.
Boom, you get a relative risk of 3.0. So what does that mean? It means smokers here were 3 times more likely to get lung cancer than non-smokers. That's what a threefold increased risk means. If the number was less than 1, it would mean the exposure was actually protective.
All right, but wait, there's another number you're going to see all the time that looks a lot like relative risk, but it's not quite the same. It's called the odds ratio, or OR, and it's really important to know the difference.
So what the heck are odds, anyway? How are they different from risk? Well, risk is the chance of something happening out of all possibilities. Odds are the chance of it happening compared to the chance of it not happening. The odds ratio just compares the odds for the exposed group to the odds for the non-exposed group. Now, there's a handy shortcut for calculating this with a table like ours. It's called the cross product. You just multiply diagonally. So, using our smoker data, we multiply 30 by 90. Then we multiply the other diagonal, 70 times 10. Then you just divide that first number by the second.
And that gets us an odds ratio of 3.9. Now, hang on. Remember, our relative risk was 3.0. These are different numbers from the exact same data. What this 3.9 tells us is that the odds of a smoker getting lung cancer are 3.9 times the odds of a non-smoker getting it.
So why the two different numbers? Why not just stick with one? Basically, you use them for different kinds of studies. Relative risk is great for when you follow people forward in time in what are called prospective or cohort studies. But the odds ratio is what you have to use when you're looking backwards in time, like in a case control study. And here's the key thing to remember. The odds ratio almost always overestimates the relative risk, especially if the outcome you're studying is pretty common.
Okay, and this right here, this is probably the most important thing you're going to take away from this whole explainer. All these numbers, RR, OR, they can be so misleading if you don't have the right context.
Let me give you a real-world example that'll make this hit home. A study came out and found that an antidepressant was linked to a specific birth defect with an odds ratio of 5.7. That's a huge number. The odds are more than 5 times higher. I mean, come on, if you're a clinician or an expecting parent, that sounds absolutely terrifying, right?
But wait. Let's go back to our first, most important question. What is the absolute risk? Well, it turns out the baseline risk for this very rare birth defect is only 0.02%. That's it. So the 5.7 times increase brings that risk all the way up to 0.1%. So that massive, scary-sounding odds ratio, it's really just describing a tiny jump between two incredibly small numbers.
Look at this chart. It makes it so obvious. The relative jump looks like this huge, scary mountain, but the actual absolute jump in risk, it's like stepping over a crack in the sidewalk. The risk for any one person goes from basically zero to still basically zero.
Dr. Andrade just nails it with this quote. Doubling of risk is of little clinical importance when the absolute risk is low. And the opposite is true too. A small relative risk, say 1.2, could be a really big deal if your starting risk is already high, because that small relative jump can be a huge absolute jump.
So, especially for all you EMS and nursing students out there, let's boil this all down. Here's what you need to remember. 1. Always start by finding the absolute risk. That's your anchor. 2. Relative risk and odds ratios are great for telling you how strong a link is. 3. Be skeptical. A giant R or OR might mean almost nothing if the starting risk is tiny. And 4, and this is the big one, context is everything. You have to weigh the numbers against what's best for your actual patient. So from now on, when you see that headline with some big, scary risk number, you'll know what to do. You'll know to dig a little deeper, to ask the right questions, and to find the real story behind the stats. And that is what's going to help you make the absolute best decisions for your patients. Thanks so much for watching.